How to simulate loading, error, empty and successful server responses in a React app using queries and building basic user experience to handle those states. Now, simulating server states using queries. What does it even mean? In the third part of the React app structuring video series, we have introduced the concept of queries as a part of a module of a React application structure. And within the query we have developed during that video, we are not doing anything much but merely returning the items fixture. But even with this primitive functionality, we can now confidently claim that one of the 4 states we are aiming to address in this video, the success state, has already been implemented, since we can see in our application the items data. Now our task is to mock up another 3 states within our to-do application and make our user interface to react on them accordingly. The application we are going to work with is available on the public repository. A link to the starter code as well as the one to the finished code are in the episode description. When you will check out this repository, a start from you will be highly appreciated. Now let's get back to the code. Since, as we have already said, the success state has already been implemented in our application, the next logical step would be to mock up the empty state, meaning when there are no items. In fact, the empty state is also a successful response, but it just often needs special treatment. And simulating it within our query would be as easy as assigning an empty array as its data. If we now take a look at our application in the browser, we will see nothing but just the title. And that is okay because our to-do list is empty. However, we don't want to confuse our user with such blank screen. Instead, we will want to display something meaningful to them so they understand that there is no data yet. So in our component, we can do this within the JSX conditional query. If the todos array is not empty, then display something, otherwise something else. And when it is not empty, we will just use this list we are rendering now. Otherwise, when it is empty, we will want to display a message that informs our user about it. For example, that there are no todos so far. Of course, nobody can guarantee us that the todos will ever be defined, so we will just add a condition to check this explicitly. This condition will allow us to get rid of this operator, and also we are not going to need this condition over here. So what are we seeing in our application? Looks like we see some sort of empty state screen. I would just make it a bit more nice. For example, by displaying it with the secondary text. And perhaps to add some spacing on the top of that. Yeah, this looks a little nicer. Now let's get our success state back in our query. And we are ready to make our first commit. Alright, we are doing great so far, but every interaction with the real server comes with latency, and this latency is often quite notable. That's why it is important to implement the handling of the loading state within a user interface. And to simulate this loading state in our query would not be difficult. We just need to set this loading property to be true. Now we are ready to apply our loading property of the query to our component. And within our task, when the loading is true, we don't want to take in count any data, regardless of whether it is set or not. To do that, we will add a rendering condition that, in case if the loading is true, will display for us a loading screen. To represent the loading state within our user interface, we will use the circular progress feature of the Material UI library. Here is how it works. I will just center it in the screen. And add some more spacing at its top. Yeah, that looks nicer, doesn't it? Alright, so now we have implemented the basic loading screen, but the loading state isn't meant to be permanent, because otherwise it would mean some problem. What we instead want to do is to display the loading state during the server request, and once the data is fetched, to represent this data. And we can simulate this behavior in our query as well. For this, we would need to add a use effect here. And within the use effect, we are going to set a timeout, which will simulate the latency. And let's say the latency equals to 1 second. Now, within this effect, we are going to need to change those properties. It means that we are now going to need state variables for them. So let's define them right now. For the loading, the loading will be 2 by default. Now as well for the data. The data by default will be undefined. However, we will restrict its type to be todo item array. Now, to simulate the actual successful response, the first thing we are going to do inside our timeout is to set our fixture as data and to set the loading to be false. Also, we will need this effect to happen only once. So just in case, we will add an empty dependency array to our use effect. Now what we can see in our browser, there is a loading state for about 1 second, and then we can see some data. It means that we have successfully simulated server latency and are handling it with the loading state. So let's commit these changes as quickly as possible. Now, the last but not least is when something goes wrong with the server. I'm talking about the error state. It is time to use our error property that we had defined in the query result interface. Here is it. To simulate the unsuccessful response, we will need another variable, state variable for error, which will be undefined by default similarly to the data, and we will restrict its type to be the error. Now, to actually simulate the unsuccessful response, we will need to set the error to be some test error. Now, inside our component, we are ready to apply the error property of the query, and similarly to the loading, we are not going to take into account any data when the error is defined. So for this, we will create another rendering condition, which in case of any error will display us a message that something is wrong. Yeah, something like that. However, I would display it with its appropriate color. Yeah, and as we can see, we have our error screen displayed after some loading state representing latency. It means that we have already accomplished the error handling within our application. But before making a commit, I want to say some words about our code. The code that we have in our component can be considered as very much production code. It means that this code will be functioning for your end users as well. On the other hand, what we were doing during this video inside the query is just manual testing, which has permitted us to build this code, however. It means that this code is not going to be used by your end users, but it doesn't mean that you are not going to need it anymore. This code will remain inside your code base during all your application's lifetime for the cases when further manual testing is needed. And one more thing is, since this is the code for development purposes, it is likely to break our ESLint rules, for example, like in this case. It means that it makes sense to disable ESLint checking for development only code. Now, when those warning is gone, we are ready to make the commit. In the future videos, I will show you how to write production queries that will make real requests to real servers, how to switch between development queries and the production ones when needed, and many other useful things. So subscribe to this channel right now in order for not to miss those topics out. Also give a like to this video and leave your comment down below. My name is Anton, don't stop coding, don't stop growing.